here is group 4, our presentation on measuring the variability of chain ladder reserve estimates. Our lovely writer today is Angela Coe, and our presenters are me, Kedra King, and Emily Kangas. So let's go ahead and start with an overview of what we're going to talk about today. So we're going to talk about the chain ladder method. We're going to review notations and a first analysis, age-to-age factor formula, variability of the ultimate chain amounts, claims amounts, and checking the chain ladder assumptions. Then we're going to go through a numeric example and a conclusion. So what is the chain ladder method? It's most popular method for estimating outstanding claims reserves. So we can use it as based on an incremental or cumulative loss payments from the triangles, like this table over here on the right. So this top table is increment. So each year there is increments and you get a total year. Down at the bottom, this table shows cumulative. So it's really just adding each year up and you get a total at the end. Okay, moving on to notations and first analysis. So we can say CIK is the accumulated total claims amount of accident year I, where I is between 1 and matured I. We want to estimate the values of CIK for I plus K is greater than matured I plus 1. So we have RI, which is claims reserves, equals CI matured I minus CI between matured I plus 1 minus little I. So the outstanding claims reserves of accident year I as CI matured I plus 1 minus little I has already been paid and incurred up to now. So our first formula we have is the chain ladder method consists of estimating the ultimate claims amounts CI matured I, which equals CI matured I plus 1 minus little I times F matured I plus 1 minus little I, and so on and so forth, where I is between 1 and 2. We also have age-to-age factors, which is notated as F of K, and this equals the summation of CJ, K plus 1, divided by the summation of CJ, K, where K is between 1 and matured I minus 1. An increase from CIK to CIK plus 1 is a random disturbance of expected increase from CIK to CIK FK. And another formula says the chain ladder method assumes existence of accident year independent factors. So this is really the expected value of CIK plus 1 given CI1 to CIK, which is the same thing I mentioned earlier, CIK FK, where I is between 1 and matured I, and K is between 1 and matured I minus 1. So we can have the assumptions below as it uses the same age-to-age factors, and it uses the most recent value of CI matured I plus 1 minus little I as basis for projection to ultimate. Here's one example we did in class with Professor. So the top table shows the incremental values and the bottom table shows the cumulative values. So we can calculate the loss reserve using the chain ladder method. In this example, we calculated the reserve using the ultimate losses and the paid losses. So we can find our loss development factors as 1.5 for 0 to 1, 1.13 from 1 to 2, and 1 for 2 to 3. And all of these are the years past these years over here. Like I said before, cumulative, we're adding each year up here. So 10,000 to start. Then we're going to add this 5,000, so we get 15,000. And then we're going to add 2,000 and we'll get $17,000. And then, in order to find our next year, we're going to take the year previous and multiply it by our loss development factors. And then same thing over here and here. Take the year before and multiply it by its loss development factors. So we'll end up with our ultimate losses as follows. And then our paid losses are the losses over here in these boxes. And then to calculate the reserve, we'll take our paid losses and our ultimate losses and find their difference. So here we have 0, here we have 0, here is 2,893 and 42 cents. And then we'll have 12,217 and 58 cents. Then we'll total up our reserves with a total of $15,111. So our H-to-H factor formula, a key to measuring the variability, we have an additional assumption that in the chain ladder method, we don't consider any dependence between the accident years. This implies the assumption of independence in the chain ladder method. So for the fourth formula, the variables CI1 to CI matured I and CJ1 to CJ matured I of different accident years where I does not equal J are independent. Now, please note that not every assumption can be taken and met for every runoff triangle. Another assumption says that the fact that the chain ladder estimator, FK, uses weights which are proportional to CJK, therefore means that CJK is assumed to be inversely proportional to the variance of CJK plus 1 divided by CK, given CJ1 to CJK. So the variance is CJK alpha squared K, where J is between 1 and matured I, and K is between 1 and matured I minus 1, which unknown proportionality constants, alpha squared K, is where K is between 1 and matured I minus 1. Again, not every assumption can be taken and met for every runoff triangle. So here's another example using our H-to-H factors. So we can compute the average H-to-H factors down here, where actuaries use several different methods. So here we have the arithmetic method, the geometric method, and volume. So these are basically the averages of 3 years or 5 years, depending on what you're looking for. So here we're looking for the 3-year average. Here we're looking for the 5-year average. We did compute this example in class with the professor, so I would hope that you guys understood. If not, you can definitely leave some questions in the comments below. The variability of the ultimate claims amount. We want to know if estimator CI matured I is at least one average equal to the mean of CI matured I, and how large on average the error is. So we can denote that with the formula below. The expected value of CI minus CI squared given D, where D is CIK, given that I plus K is less than or equal to matured I plus 1. And we want to know the error due to future randomness only. So here's a couple more formulas. The equality of the mean squared errors also implies the equality of standard errors. So the standard error of the claims reserve equals the standard error of CI matured I. So the standard error of CI matured I squared is CI matured I squared times the summation of the unbiased estimator over the H-to-H factor multiplied by 1 over CIK plus 1 over the summation of CJK, where our unbiased estimator can be found as 1 over matured I minus k plus 1 times the summation of CJK times CJK plus 1 divided by CJK minus H factor, where k is between 1 and matured I minus 2. A symmetric 95% confidence interval for Ri is then given by this formula. And we can assume log normal distribution leads to sigma squared I is the natural log of 1 plus standard error Ri squared divided by Ri squared. And mu is the natural log of Ri minus sigma squared I divided by 2. And the last formula we have is for overall reserve estimator, R equals R2 all the way up to R matured I. We have the standard error of R squared. This is a very long formula, but I think we can get the gist of it. It can be used to establish a confidence interval for the overall reserve amount R in quite the same way as it was done before Ri. And here we have our three assumptions. The expected value of CIK plus 1 given CI1 to CIK is CIK times the H to H factor. The independence of accident years and the variance of CIK plus 1 given CI1 to CIK is CIK times alpha squared K.
And in conclusion, we can conclude that the chain ladder method has applications beyond just providing a confidence interval for ultimate losses, which can also be compared to alternate estimates for ultimate losses, including expected claims. And a good estimate for the ultimate losses is in the appropriateness for use of these methods by assessing the confidence interval range. However, one caveat of the chain ladder method needs to be addressed while working with data with no distribution, and the estimators for the final few age to age factors are based on small observed amount of the available claims. And similarly, the estimated ultimate losses for the most recent accident year has a large range due to the incurred but not paid claims, and the point estimate for these incurred but not paid claims vary a lot. Chain ladder methodology still stands a good modeling tool for variability of reserves, but still needs to be reviewed periodically as input variables may change the results based on the development triangle. But generally speaking, chain ladder methodology is a good method of modeling reserves and can still be understood by non-actuarial users. Thanks for watching our video, and if you have any questions, please feel free to drop any comments or questions and we'll be happy to answer them. Thank you.